We've all learned of the alchemists of old, who mixed molten metals in all possible combinations to try and create gold. Spoiler alert, they were never able to create gold, but if they tried to make diamond instead, they might just have been successful. Because diamonds, rare valuable diamonds, are made out of exactly the same substance as a common material, graphite. Let's take a look. You can buy a graphite pencil for just a few cents, but we pay thousands of dollars for even a small diamond. They're both made out of the pure element carbon, but just by touching my pencil to a piece of paper, the carbon atoms in graphite break off the pencil's tip onto my paper. Yet diamond can somehow cut through steel and is one of the toughest naturally occurring substances. When there are multiple forms in which one pure element can exist, they're called allotropes. Carbon has many allotropes, including diamond and graphite, which we're all familiar with, as well as lonsdaleite, fullerene, amorphous carbon, and more. Let me explain how allotropes can exist with wooden blocks. Each of these blocks will represent one carbon atom, and the glue represents bonding between the atoms. In graphite, the carbon atoms are bonded to each other horizontally and then stacked to form vertical layers. These layers of carbon are able to easily slip off onto our paper when we're taking notes. Diamond, in contrast, is linked together much more strongly. The carbon atoms are bonded to each other both horizontally and vertically, which makes it much more difficult to separate part of the structure from the rest of it. A carbon atom has 4 valence electrons, and in order to be neutrally charged, must reach 8 valence electrons, or a complete octet. When atoms bond together and share electrons, they form covalent bonds. In diamond, each carbon has 4 covalent bonds, enabling exceptional durability and rigidity. However, each carbon in graphite only has 3 bonds, meaning there are excess electrons in the structure that are not participating in bonding. These electrons still help the layers of graphite to stay together, but only through van der Waals forces, which are significantly weaker than covalent bonds. With this knowledge of how diamonds are structured, scientists have become modern-day alchemists of diamond instead of gold, growing diamond in labs by processes known as HPHT, high pressure, high temperature, and CVD, chemical vapor decomposition. These methods have produced diamonds that are just as strong or stronger than naturally occurring diamonds, and are indistinguishable from them except by a professionally trained eye. It's clear that the organization of the atoms in a substance is just as important as the quality of the atoms themselves to determine the properties and utility of that substance. With this in mind, even though graphite and diamond are both made out of carbon, it may not be the best plan financially or practically to take notes with a diamond ring, and you definitely shouldn't propose with a pencil. But still, the discovery that these substances are so similar to each other is monumental in the world of science.